These are Google Slides too, so I think Peter has the link. Well, thank you so much for the opportunity to talk with you today. And I have some intro slides to motivate need for training, but given Peter's intro, it seems like there's not that much need for that. But just to highlight, as Peter said, sort of where we're coming from and where we want to go in the carpentries. So overall in research, there are vast amounts of data that are changing the way that research is done. And even in fields like high energy physics that has been data intensive, we are generating even more and more types of data. This is the 4 V's as described by IBM. So with the volume, the velocity, the variety, and then the sort of more recent V addition, the veracity. And so we know that this data has such potential, but its limits are our capacity to work with it. And that includes several things. One, just a data workflow knowledge, how to do software development and efficient and effective software use, including things like programming tools, command line. And I pulled a couple of quotes from actually this 2011 report, and it's interesting to Peter say, you know, talking about this for the last 5 years, because this report statement, I think, would still be relevant today, is that in particular, application development is crucial for doing things in high capacity, high data situations, high performance computing, and to address new operating models and new hierarchies that are coming out for exascale systems. And I pulled this line as well because I think it also highlights the importance of training in bringing more people into the field. So this one highlights encouraging members of underrepresented groups to pursue careers in HPC. And so that is really true, I think, in high energy physics as well, that training is a real opportunity to bring more people into the field and broaden the diversity and perspectives of people in it. So we're all motivated, we're all excited about what training can do and how important it is in our ecosystem. So how do we scale this data and software skills training along with data production? And so we're approaching it in the carpentries as building skills and building community, and having this model of training in the gaps. So what that means is that it's accessible, so it's in a time and place that people can attend it. So that often means not a semester-long class. Approachable, so at people's levels, so meeting people where they are, not being really too advanced right from the start, or representing where they are in the domain so that they can approach the content and not be overly intimidated by it. Aligned, so it's actually things that they need to know and use right now. And then applicable is similar in the sense that they're going to leave the training and go be able to use those skills and continue learning. So that's kind of our model for how we're thinking about delivering training. And then we do it through peer-led, hands-on intensive workshops. So peers teaching other people. It helps meet some of these things around aligned and applicable because peers are teaching the things that they're using that are important to them. And then the hands-on component gives learners the opportunity to try things out, to not necessarily get it right the first time, but to keep trying and to iterate it in the context of their learning environment. And I'll talk more about these last 3, volunteer instructors. So that's a way of scaling the number of people who can teach these workshops. Open and collaborative lesson materials, again, scaling who can develop and who can use and who can contribute to lesson materials, and creating and supporting a community because we are really trying to build a community of practice. So we're a nonprofit organization that trains people in software development and data science skills for more effective work and career development, and builds community and local capacity for teaching and learning these skills and perspectives. So I talked about this workshop model. So most of our workshops are 2 days, active learning, this hands-on. We follow an I, we, you model. The instructor teaches something, we do it together, and then you try it on your own. We give feedback to learners throughout the workshop. Our instructors are trained in how to teach. And overall, it's really important that we create a friendly learning environment, so a really inclusive learning environment. So we have things like a code of conduct. We talk about pacing, about helping the people next to you. So really making it a space where people feel like they can learn. And Peter mentioned software carpentry and data carpentry. So those are two of the carpentries. Now I'll also have library carpentry. And I'm going to talk a little bit about what the different skills and perspectives are in these different carpentry ones, because I think I'll be curious to hear if library carpentry speaks to this community as well. But I think both software carpentry and data carpentry have some relevance in terms of what people are looking to learn. So data carpentry is focused on data, so how to work effectively with data, and it includes domain-specific content. And it's meant to represent the whole workflow of working with data, so starting with data organization, sort of tidy data and project organization, going through data exploration and visualization in R or Python, and then the idea of automating some of these data workflows. So, and then because it is focused on working with data, we use data in particular domains so that it matches where people are. They've already seen data sets like that, so they come to the workshop, it's something familiar to them. They're building these skills on top of a framework they already have. Similarly, when they leave the workshop and they go to work with their own data, the examples used in class would be relevant. So we have these domains. We have ecology, and that's working with tabular data, so like spreadsheets. Genomics is working with genomic data, and that includes cloud computing, working with bioinformatics tools at the command line. Geospatial, so organizing and working with geospatial data in our social sciences, so that's similar to ecology, working with tabular data, but with social science data sets. And then there's development in astronomy, digital humanities, image analysis. So there's a lot of room to expand here as we're thinking about different domains, different types of data within those domains, and making sure that the skills that we teach match that data set. So you're going to probably, teach command line if a particular domain has a lot of command line tools, for instance. So software carpentry. So software carpentry is focused on software development of best or good enough practices. So that's sort of after you've sort of started working with data. So that data carpentry actually assumes no prior knowledge. So it's really entry level, sort of creating the on-ramp to working with data. Software carpentry works best if you have had a little bit of experience working with R or Python. And now you're looking to maybe develop some packages, do a little bit more automation. So that focuses on the command line, version control with GitHub, programming in Python or R. We also have some lessons on Make. So it is about kind of those next steps in working effectively with programming to analyze data or to develop software packages. So library carpentry is the newer carpentry, and that is focused on teaching people in library and information and related roles how to think about sort of some of the jargon in data science, identify and use best practices in data structures, think about things programmatically. And it's to empower library community to work with library data, but also to engage with researchers and IT around data, because the library community has a lot to offer in terms of thinking about archiving and storage and data management plans. So it's a way to engage sort of the whole research academic community in thinking about data and software. So these are some of the lessons too. So I've just sort of given a whole list of all of the skills in these different workshops, but overall the goals of all of these workshops are, yes, to teach the skills, but almost more importantly, to get people started and introduce them to what's possible, to build their confidence in using these skills, encourage people to continue learning, and have a positive learning experience. And so using this model, so far we have over 1,600 instructors, over 39,000 learners, and over 1,700 workshops. And we've had workshops worldwide, so this is a map of the number of workshops sort of over time. And so you can see, got them all 7 continents, one in Antarctica this last year. And so, right, how do we run that many workshops? How do we reach that many continents? And it's through our volunteer instructors. So we have an instructor training program that's also a 2-day workshop that all of our regular workshops are in person. Our instructor training is in person or online. It still takes a hands-on approach, but it teaches people educational pedagogy. So how to teach generally, as well as for carpentry's workshops and for data and software specific skills. So what's really interesting about this is that in our workshops, one of the questions that we ask is, how much teaching training have you had? And about 80% of participants say that they've had no training in how to teach. And these are graduate students, postdoc, faculty. So this is in some cases some people's real first opportunity to really learn about teaching. And it really makes a difference in how people approach the teaching and their confidence in approaching the teaching. So then our curriculum. So this is another thing that's really important in reaching all these places. It's all open and collaboratively developed. So it's all on GitHub. So you can contribute to it just like in open source projects. We have, I think, about 44 lessons. So we're effectively sort of have 44 open source projects and we have maintainers and curriculum advisory committees that sort of oversee the content. But it does allow a lot of people to keep things up to date, to make sure that things are working. So that's a really important part of maintaining applicability and then access to these curriculums for anyone to use or reuse. So they're all CC BY. So one of the other things, given that we have all this curriculum, and like I talked about for data carpentry, there's a lot of interest in continuing other curriculum development. And so we're trying to develop more infrastructure and guidelines to support more lesson development. So we're planning to do a 2-day workshop on how to develop curriculum and have something called Carpentry's Labs that could be for more community contributed lessons. So finally, kind of this last piece about community. And so overall, our community we just are really fortunate to have people who are really excited about software and data skills and sharing them with others. So once you go through instructor training, you sort of join this community of people that are excited about some of the same things as you are. We have a mentoring program and instructor onboarding to help new instructors. We have discussion groups and community calls to connect people about teaching or really kind of anything else they want to talk about, email lists, and opportunities for instructors to go teach at other institutions. So if a workshop is in one location, we get calls for instructors, someone can go somewhere else. So we have opportunities for instructors to visit each other. So this is kind of about the global community. It also helps build a local community and local capacity for training. And so when you have an instructor training and you have multiple instructors from an individual site, they're able to self-organize workshops at their institution. And so you start to build not just like, oh, come in and do one workshop and then go away. So you have multiple instructors. You can keep running workshops. Those instructors talk to each other. They continue to engage with learners. So that's really another piece of this scaling, is by sort of feeding these communities at institutions that then have their own capacity to grow training. So I want to just touch, on the outcomes and if this is effective. Yeah, so we've run a lot of workshops. What has that meant for the people that have gone through them? So we do short-term surveys. Those are just right after the workshop. And then long-term surveys 6 months or more after the workshop. So in both of those surveys, it shows that people are learning the skills, putting them to practice in their work, and importantly, have more confidence in their ability to do computational work. So these are just a couple quotes here. about how it's changed people's workflows. So just who takes the workshops. So this is representative across all of our domains. About 50% are in biology. So we have a pretty good spread. You can see, though, most are graduate students and postdocs. So this confidence piece, and it's important because it is what allows people to actually want to use these skills and keep learning. So this is after just 2 days. These questions on the left, so the first question is, I think I could write a small program to answer a question in my research. So it goes from being, a little under a 3 to a 4 over just 2 days, so almost a full point. And we see similar things. So the overcome problem is I have the ability to overcome a problem in my programming. Confidence programming, I have confidence in my ability to do a small programming task. So even just in 2 days, people's confidence increases pretty dramatically. These are kind of some of the words that we use to describe the workshop and people use to describe the workshop. And I put it up here because I mentioned that really important part about being welcoming, being inclusive. So you see a lot of like helpful and relevant support. Usually see helpers, instructors in here because that's really what really makes that impact around that confidence piece. This confidence also persists long-term. So we have 404 people who did that 6 months, and this definitely has this skew in terms of who answers these long-term surveys. We send them out to all people who participated in a workshop. But so almost 100%, more than 6 months after a workshop, say that they are more confident now in their ability to program than before the workshop. And many people go on to continue learning. So again, in this long-term survey, do they agree that they have continued to learn more over the workshop? Most people agree or strongly agree, so it's inspired them as this is something that they want to do. And then this is a question about how the skills are affecting their work. So people are saying they're improving their overall efficiency, improving ability to analyze data, improving ability to manage data, and not that many people are not using them or are not finding them helpful. Again, so sort of long-term, they say what were the kind of the outcomes from this workshop. So Git here is a big one, GitHub, Python. So here you start to see the skills come out a little bit more. And then finally, people like the workshops. So almost 80% of participants have recommended the workshops to others. So this is really kind of the ethos of the carpentry is this: if you want to go fast, go alone. If you want to go far, go together. So really trying to work to build a community and resources so that we can scale this and that we can work together to address data and software training skills needs across all different types of research and communities. So this has had some support from these organizations. And I will stop here, and I don't know my time. I can answer any questions if there's still time.
You absolutely have time. Thank you. This is great. Okay. So let me frame it. I will ask for questions in a second, but let me frame it a little bit, which is that I think, Tracy, as you've understood, high energy physics is this highly organized at the level of a community. It's a community which, because of the, on the experimental side in particular, has these big experiments, has a lot of structure to it. So, and despite that, we're not quite as organized as you would expect, but we're getting there. And in fact, the funded things that we've had in the past few years actually give us the opportunity to organize at a level which we can, in principle, affect thousands of people. Right, both in the U.S. and more broadly, that's where we're interested in not inventing this entirely ourselves, right? So absolutely, the carpentries has been already been the inspiration for some of the internal energy physics activities in the domain of training, and now we're sort of trying to understand how to go forward from here. So on that note, I sort of open it up to everyone else to ask questions or put forward thoughts or ideas. Everybody shy? Any questions?
Tracy, this is Sudhir. I have a question about you said most of the participants are from biology, if I'm not wrong. My question is there anybody from physics?
Yes, definitely. So, in fact, and I might get what you mean by physics wrong, so please, please feel free to correct me. But so one of our earliest supporters was the Space Telescope, STSI. And so we've had a lot of people in that community as instructors go through training. They run software carpentry every year at AAS. We're developing astronomy curriculum. We're running instructor training for the LSST. What's that stand for? Large Space
Synoptics.
Yes, telescope. So in that community as well. So definitely we have people in the physics and astronomy community. They're just a smaller proportion, I think, maybe of overall researchers. But maybe also the shift is a little bit different in this community. So right, for biologists, there's now all of this digital data that they didn't have to work with before, and there were no training options. No one in biology, even still very few, have this kind of training. So there's such a demand and just crucial need for it. I think maybe in physics, people are a little more computationally oriented. Maybe they know more about command line, and so maybe the need to shift to petascale is different in terms of motivation than it is for biologists who need it to just like start anything. That's just one speculation, but it also could be about perspectives on training or the types of content we have available. There's lots of different reasons.
Okay, thank you.
I have a question. Do you deal with people that need to learn or want to learn C++?
So we do not currently have any curriculum around C++, but we certainly could. We develop curriculum as motivated by the community. So there hasn't been a lot of demand for C++. And I wonder if that's because it's more available as a course, like as a university course. So like,
yeah,
I mean, I don't know.
What we find in our science is that yes, you can find computer science graduates who know C++ coming out of school, but a very small fraction in physics, for instance. Physics undergraduates or even graduate students. And for my laboratory, there's been quite a call for, please teach us C++.
Yeah.
So.
Yeah, I think I think like Peter's talking about, that would be, I think there's an opportunity within your community to look around and say, what are the skills that we're sort of finding over and over again people want to learn, people need, that they don't have, and to work together to develop those resources.
Yeah, I mean, just to follow up on that, because I was going to ask exactly the same thing. I mean, looking at the core lessons, things on the shell, Git, and Python are very interesting for our community. I know that people have used those materials already. I think when you look around C++, I'd actually say that there is nothing that's equivalent in terms of level and quality that's similar to what you do in the carpentries. And often in high energy physics, what we end up being dragged into is teaching very specific skills that people need to access Atlas or CMS data in C++. And we don't do so much on teaching people some of the core fundamentals in the language. And it's always struck me that there are other communities out there who must be using C++. I know there are, even in astronomy as well. And it would be interesting to, I think, for us to invest in trying to get some kind of core C++ curriculum up and running to teach people good practice in that language, because it's very easy to do C++ badly.
Yeah, that would be, I think that would be great to have the development of that as a resource. Because you're right, this is, I mean, the reason we teach these core things is because you take the stats course and they're like, we assume you know R, and no one ever teaches you R. And so it sounds like a similar kind of thing where you're like, let's use this tool that's C++ based, but never teach you C++.
So Graham and Liz, maybe I can interject something here, which is that I personally, this is Peter, hi, I take a very sort of first we take Manhattan, then we take Berlin perspective of this, because I have, for better for worse, at the age I'm at, I have a medium long-term perspective on it, which is that the best I think we can accomplish is to establish a structure within our community in terms of the kinds of training we can provide beyond what we do today, which is absolutely ad hoc. There's a structure which comes from the carpentries. There's a structure which potentially comes from more advanced training, which maybe Sudhir will talk about. And establish that, and then begin to discuss with, we can't do everything ourselves, to discuss with the universities what we require as prerequisites. And then, maybe there can be extensions to what's provided by the carpentries or other things, right? But the point is, the very best we can do is establish, given that we have this international community, we have something absolutely particular, sort of scheme for how it all works, right? Like how all the pieces fit together, which can be part carpentries, part experiment-specific, part advanced training, et cetera, this pyramid, which we'll see later. And, based on that, we can go backwards and say, what are the missing pieces? And C++ is obviously a challenging piece, which, requires, a particular in-depth training, et cetera, and we see where we can go with that. So I think getting to C++, which is a particular sort of leaf, I think absolutely in our community requires establishing a structure where we can say, look, this is our structure, and this is the missing piece. And to do so in a sustainable fashion, which is the thing, Liz, for example, you asked the question, but as you know well, you tried at Fermilab, and you did a sort of one-off, but like, where do you go from there, right?
Yeah, I think one of the probably most impactful things you could do is do a lot of instructor training. So getting people trained as instructors gives them the mindset to think about curriculum. It also connects those people within your community who are excited about training other people, and helps maybe some people that, one real challenge, right, is that expert mindset. And so once you've been doing it for a while, you forget what people didn't know, but even more importantly, you sort of forget how to interact with them. So instructor training helps you sort of remember that. So it also can help grow a community of people, even if they're not teaching, that are maybe better mentors, thinking about how to interact with people new to a skill, even outside of a more formal instruction. And then they could think about, oh, what materials do we need? And, what should we do next? You have a set of people that have more of a shared experience in thinking about these things together.
Yeah, I agree. That's worked really well for some of the things Sudhir probably will talk about later, but I was just asking you because you could provide a seed for that if you had it. So that was kind of the genesis of you have to start that training of training of trainers somewhere, right? And that's what I was looking for. But okay, I have other ideas for that too. I mean, I do consider it now. At least I've been able to get the powers that be at DOE to recognize that training for HLLHC, C++ software is an absolute need, and so I do have some support for that.
Great.
So Liz, I think so. Liz is the CIO at Fermilab. So I think Liz, one of the most interesting things about the carpentries is precisely what Tracy said, which is this model of building a community of instructors, right? Even more so than the material or the actual activities, is really building out the notion of a community of people that are interested in making this happen, right? So I hope that on the DOE side, right, like everything I talk about is on the NSF side.
Right.
I hope, and please help Liz, that the DOE will buy into not owning it itself, but will buy into being a leader and all this kind of stuff in a community where it can build out. You know, the labs are, you know, hydrogen physics, absolutely, the labs are a resource. That's where the vast majority of our developers are. That, you know, that it's built out in a way that's coherent with the rest, that adds value, as opposed to assuming that they just do everything themselves. So please work in that direction, Liz.
Yeah, I am. I mean, after all, their initial starting point was, we don't do training because education is the NSF's mission, not ours, right? So it took me a long time to get them to the point where actually we have a strategic need to make sure that the software is good, you know. Otherwise we'll be spending a lot of money on computing, right? So I don't think anybody wants to take anything away from the NSF here. I think it's just, you know, a recognition that they should support it in some ways, and collaborating with NSF is perfect argument for that.
More so than NSF, I think the carpentries has, at least at the, again, Sudhir will come back to the sort of multi-level training scheme we have, but the carpentries at least has created a framework for these things, for the sort of introductory, bringing people up to the initial levels of training. And I think absolutely we should find ways to be synergistic with that, and amplify that, and to benefit from that. Okay, so Liz, Sudhir, and I have, with Tracy, have gone back and forth. Does anyone else have comments or thoughts?
Yeah, I was just gonna make one comment. So I don't know if anyone from LHCb is connected, but I know that I think back in a few years ago, Tim Head, before he left the field, had started the LHCb starter kits, which I think might have actually even been done in collaboration with Software Carpentry. So I dropped that link in the group chat, but I just think that it's been nice to see that LHCb has actually already kind of started to do things along these lines. I mean, specifically with more towards the Python stack, and not what C++ has been being discussed. But I think it's interesting that, you know, they've already kind of started on this. And correct me if I'm wrong, but I think that they might have actually either worked directly with Software Carpentry to get started, or just borrowed very, very heavily from the scheme.
Yeah, I think Tim Head is involved in the carpentries, so maybe it was more a borrowing than an active engagement. But I don't think I've talked with him about this in particular, but other people might. Greg Wilson in particular might have chatted with him about this. Yeah,
this is
great.
Henry. I'm the LHCb. Can you hear me?
Yes.
Okay. Yeah, I'm not as familiar with the beginning of the project with LHCb, though I do know it was based on software carpentry. I know it had the template and things like that, and the design of the workshops was built on that. It later changed and became a bit longer, and the format changed a bit, but so it's not as obvious anymore that it was based on software carpentry, but it was based on that model. Related to that, have you looked at any other links? Like you mentioned the sort of the 2-day workshop style. Have you looked at any other styles? Like if you're going to do something like C++, that might be better in a longer format.
Is that a question for me about format? Yes. So the 2-day format is for a couple of reasons. One, now there's more local instructors, but originally flying people around, 2 days was good both for them to be gone long enough, but not too long. But it is also kind of that 2-day intensive. Setting that side of time is very meaningful. But once it gets longer than that, people sort of, your brain is full. Everyone always wants the day 3 on the end of day 2, but when we do the day 3, you don't really necessarily have the energy for it. But longer formats, yes, so we've taken the 2-day workshops and spread them out over a semester. So there's a semester-long data carpentry ecology, but someone took, that was sort of a full course, but someone took just the 2-day and spread it out over a couple hours for an entire semester. So you could take, if you say your C++ module, you think it's like a 2 days worth of content, you could spread that out over time. The longer format, unless it is a class, tends to drop off. People stop coming back as much. So retention isn't quite as good in the longer format. There's also the short form, you know, like the 1-week course kind of stuff, but I wouldn't teach probably just C++ for a week, but you could put that in with other specific topics, or take maybe an existing 1-week, you know, high energy physics boot camp and put in some like core C++ stuff in there, whereas right now you might just sort of assume that people come in. I don't know if that answered your question. So yes, there's lots of different formats. People's attention varies.
Yes, I think it did answer. Thank you.
To be clear, I think one of the most interesting things actually is, so, you know, in high energy physics we have this, because we're a big science and because we're sort of organized at this multi-institutional, national, international level, that we tend to sort of imagine that within that already these absolutely complicated collaborations we have of high energy physics people, that we'll figure everything out ourselves, right? But like the intellectual enterprise that is, how do we train people in these things, is absolutely more general than high energy physics. So we don't need to, you know, invent all of this ourselves. We absolutely should interact with a larger community that's interested. Many of the topics are very similar. I see Ian Cosden at Princeton is involved, who's been involved both with the high energy physics summer school that we've been running at Princeton, and in a sort of broader mini course boot camp sort of environment within Princeton, which extends beyond high energy physics to social science to astrophysics to engineering, beyond, much beyond. Ian, you're there? Sorry to put you on.
Yeah, I'm here.
Yeah, do you want to say anything? I mean, I think there's a framing of the thing which is larger than which absolutely is larger. I don't know if you want to interject. I put you on the spot, Ian. Hi, Ian.
So, say again. What you're asking about that? Is it larger than just high energy physics?
Yeah, I mean, you sort of participated in. I'm asking you to speak to maybe more than Tracy, to speak to the high energy physics people, to say, look, you know, what I see and what you should see in the CODASEP, which we've run for the high energy physics people, is you know, essentially has common roots more broadly, and what you see in terms of interactions between the two, because that's where you sit, right? So.
Yeah, right, absolutely. So as Peter said, we do training for everyone under the sun on campus here, where high energy physics is just a small fraction, and we see largely the same questions, the same need for training, the same curriculum essentially as forming this foundational skills for which more domain-specific things can be built on top of. So whether that is C++ in your particular domain, or whether it's more advanced R or even MATLAB in the engineerings, but having this foundational approach to what we do, how to do it best, or as Tracy said, good enough practices is critical, and certainly lends itself to being somewhat modular, as in put this curriculum in, and then build on top and go from there. I think this is a fantastic place to start when you're thinking about a sustainable training framework.
So I would add one more thing on top, which is that maybe to address a little bit Henry's point, which is that so for Tracy's benefit, LHCb is one of the experiments at CERN, which has inspired itself from the software carpentry to sort of develop some training, both material and sort of context and community within a particular experiment at the LHC at CERN. The one thing that they lacked, given that was kind of a community-driven effort, was in the end funding to say, look, we want to be a partner with the carpentries, to say we'll put some funding on the table. As I think you've understood, we have some, via these various projects which we've got funded by the NSF, we have some funding basically to engage, proactively and say, we'll put the funding, we'll engage funding-wise, not only sort of like aspiration-wise, in terms of the carpentry. So that's one of the reasons we wanted you to talk today, is to see where we could go with this, with a more sort of formalized training as opposed to just being inspired and inventing it ourselves.
Yeah, no, I really appreciate that, doing things together, not reinventing wheels. So I think that could be really valuable. There is also a little bit of something to be said by taking an existing community and building with that community. So I think it's okay to sort of end up maybe with some high energy physics, specific contents would make sense. Like even if it's C++, using high energy physics examples would help it resonate more. And even thinking about sort of a Carpentries high energy physics instructors email list or something, because it does take people who are excited about the same things and brings them together a little more tightly if there is already that existing community.
So I've been involved in running sort of 1-week summer schools since, let's say, 10+ years in sort of software related topics. And one of the things that I think is actually super important, which you've addressed in the Carpentries, is this concept of instructor training, which is that despite the enthusiasms of many people, of course, I certainly don't have this delusion, but I think many people realistically don't have this delusion, which we don't know how to teach. We're inspired to teach, right? We're inspired to try and explain, but absolutely we need input on how to do that in the best possible way. right? So one of the things I think that the membership in the carpentries, which we should build on, is the instructor training, to actually find a way to actually engage people and sort of give them, best practices and ideas about how to do this. And the experience I've had with the schools that I've been involved with is that it's very much an iterative thing, which is people try, they bring forward their material, they bring forward their ideas of how to interact with students, and it's iterative. One learns on the first attempt and improves on the second attempt, and so on, right?
And there's definitely something to the iteration that always has to happen, but it's nice to start a little further along by having some training in how to teach. Right? I mean, teaching is, we know things about teaching that are effective from a research perspective. So that's what our instructor training is looking at that that pedagogy, that research and education, and finding the things that, not to take a 2-year-long teacher training course to pull out the sort of the key elements that are going to have an impact on the type of training that we do, and teach people about that. And we also really emphasize the inclusive training, which is even kind of something a little bit different around creating that welcoming environment that you might not find in some other how to teach type opportunities. So it is like anything. If we have a chance to learn about it, it's valuable.
Okay, so this is, as you see, we're trying to organize and fund membership in the carpentries to be able to organize this within our community. I hope that will converge soonish. But I absolutely understand that the key ingredients of what you're trying to do are this sort of building the community of instructors, training the community of instructors in order to make a scalable enterprise. So maybe at this point, are there other questions directly for Tracy? Otherwise, we can maybe proceed to Sudhir's talk. Other questions directly for Tracy? Going. Okay, so why don't we proceed, Sudhir? Are you set up to share your slides? Why don't you talk through the ideas of what we've had some funding to proceed to do. Sudhir, you're there? I see your slides.
Okay, so am I sharing slides now?
We now see you, but we don't see your slides.
Okay,
you're handsome as usual, but we don't see your slides.
Okay, so can you see the slides now?
I can. Can others?
Yes.
Okay, because something happens when you click this. I think you have to choose audio on and video on before sharing the slides because the screen becomes smaller or something. Anyway,
we see you. We see your slides, so you're good.
Okay. Good morning, evening, afternoon, everybody. So this is Sudhir Malik. I am from University of Puerto Rico, and most of you know me from, I think the only new person from outside community is Tracy, and it was a lot of Tracy education during this meeting. I wish we had something left after my talk. Anyway, so I guess what Tracy carpentry has achieved for by and large non-physics community is what we are trying to achieve for physics community, in particular the particle physics community via this IRS HEP funding, and I'm the training education outreach coordinator for this. So this is a recycle of my slides shown at the University of Chicago, and I was pretty shameless. I didn't even change the title. Anyway, so going to slide number 2. So IRS HEP, as most of you know, is an institute for research in software in high energy physics. and this received funding last year. So this will serve as an intellectual hub for software and computing challenges that are being faced or will be faced at the high luminosity LHC at CERN. So to meet these challenges, we need to build software and which will work and to meet the challenges. And this will also require formation of a workforce, because people are the real, beings who solve the software problems. So the thing is that this would require the HEP domain, our research field domain specific knowledge, plus advanced software skills, and also strong connections to other related disciplines, for example, computer science. And we would also want, the goal of this is also to have the in workforce grow, and so that we invest in the right direction. Also, training is very critical to perpetuate the learning cycle, but we have to do it in an organized and efficient way. As has been pointed out before by our LHCb colleagues, that we have these trainings there, and also several other experiments have, but they are very specific to the experiments, and I'm sure they are organized within the experiments, but we need to make a more coherent picture. And of course, we can propagate our knowledge to the wider community by the knowledge of software to the wider community by the method of outreach. So going to slide number 3. So in this situation, IRIS has a very impactful role. But what we plan to do in training and outreach is that we will coordinate the training related activities. We don't need to micromanage them, and also assemble and communicate a coherent vision for a training program in our high energy physics community, which comprise of graduate student, postdoc, and senior researchers in software and computing. And then develop a process within the community for implementing and updating this vision, and build a federated view over possible training opportunities across labs and experiments, and dedicated summer schools on computing and software, and other sources, both HEP and non-HEP. Also, this would bring together the people organizing training activities, and they can articulate the vision from their experience and develop plans to enhance the sustainability, reusability, and the impact of these training activities. So this is the word jargon of NSF also that is funding this effort. Also, work with the community to build an assessment framework. As Tracy mentioned, she presented some results from the survey and so on and so forth. So we need to do something similar to build an assessment survey, so that we can have a good grip of the impact of the activities that we plan to do. So going to slide number 4. Our training vision is demonstrated via this pyramid, or I like to call it a diamond. And this, as you can see, is a 4-layered structure. The bottom one, which we call tier 1, is more related with the carpentry activities, which we want to specifically build and cater towards HEP. So this would comprise of the basic stuff which everybody uses in particle physics across different experiments. And you can see, for example, Python, GitHub, Linux, and C++, as Liz was also mentioning. And then tier 2 is where we get a little bit more specific to the experiments. And we have a lot of activities going on within all experiments for almost a decade, where we train our students for our physics analysis related activities. And then this is we call tier 2. And then tier 3 is, which is a little bit broader developer training kind of thing, where we have different schools, for example, CodeS, as Peter mentioned. And there are other schools also on computing that happens where students from across our community attend to gain higher order skills in software. And then on top of the pyramid is top of tier 3 is the mentors, so that the goal is to prepare mentors at the top and then recycle the training culture back into the field. So we have this pyramid, but it should be viewed as a cycle, as cycling the people. They get trained and then they train in return. Very much like as Tracy mentioned, and this is all volunteer work here also. Going to slide number 5, I have taken a snapshot of tier 2 and tier 3 from the diamond, so it looks like a Christmas tree now. So current training landscape of our software computing activities spreads across different experiments as mentioned here. They are CMS, Atlas, ALICE, LHCb, and so on and so forth. So they all train their specific community in their own way. And then there are also non-experiment training efforts, which are the tier 3 kind of training efforts, which names many of the computing and software schools that happen yearly across the globe. And then there are also, we heard about data science courses, for example, at the University of Padua, which is heavily related with the data that comes from our field. So they have developed this data science course around particle physics. So this is a good example of how this can be propagated to a university level education. And also, we have people involved in training communities together for integrated software training plans. So this is the current landscape. The issue with this landscape is that there is no federated effort. There's no coordinated effort. Though we understand that we need to build experiment-specific software skills, but there are many skills that can run common across the community, and that's where IRS training program would help. And this is the vision we have in mind. Okay. Then going to slide number 6. So since, as I said, this is a recycle of the slides I showed at IRS kickoff meeting, the near-term plan that we have is to start from somewhere, build some starting point for newcomers to HEP, which are graduate students who really do not get any training in software and computing at their universities, and we have to train them as part of the experiment. So this is something that we can do outside the experiment. And then the goal is also to start in relation to that an introductory level, carpentry kind of course, and build an ensemble of it so that we can add our own flavor to the carpentry style of basic level course. So the yellow bullet I put in place because this is an update from November, that there's a plan in works to organize introductory level carpentry course at LPC Fermilab in March. It will be late March or maybe April first week. So this is in works, and soon we would like to announce it. And then the target audience would be CMS in this case to begin with, and then our goal is to propagate it to Atlas and then other experiments who can borrow or collaborate on this. And goal was also to invite LHCb, ALICE people to show their training starter kit, as was mentioned before, and then we also have the plan was to have a survey to assess the current training needs, which we already did. And there was an overwhelming response from our community. Over 350 people responded. So we will also summarize and present this at a later point, but we have the data available now. So these bullets in yellow is an update from the from when I made this presentation at the University of Chicago. So this is a near-term plan, and it looks like we are getting there and getting things rolling. Okay, so as Pete also mentioned in the beginning, that I will mention some of the funding opportunities that will support or are already supporting these activities. So first is called the Framework for Integrated Research Software Training in High Energy Physics, acronym is FIRST-HEP. So this is a funding from NSF, which is specifically targeted for training. So there's a website attached where you can get very preliminary information. We have to update that in more details. Then the second funding is available via IRS-HEP, for which this meeting is being held here, and this is a very enormous, gigantic project that encompasses not only training but a lot of development of tools for software and to meet the challenges at the HLLHC. But in this, there is a specific training activity part which also supports these activities, and there are many ways it does that. First is to help us organize these activities, and then there are fellowships for people, for undergrads, for graduate students to work on software computing projects, and then there are also job opportunities for postdoctoral level kind of people who might want to work in solving these challenges. So these two are our mainstay. But I would like to mention here that so this is mostly US based in terms of funding, but not in its reach, because most of the work that we do are international collaborations. So there is so they will benefit from this a lot. So I would like to mention here that a bigger umbrella organization for this effort is called the HSF, which is High Energy Software Foundation. And on the slide number 8, I have put some links here which you can find with respect to all these three things I mentioned: IRS-HEP, HSF, which I just mentioned, and then the FIRST-HEP. So, so this is where we stand, and we have to get started somewhere. So we are looking forward to collaborating with the Carpentries so that they can help us with the basic curriculum, and we would like to add our own HEP flavor to it. Of course, as was mentioned, that our community is not starting from scratch. They know many things, but it's a bit unorganized in some way at a common level, and that's where we want to hit and bring people together, and then propagate this knowledge back into universities, which will take time. Okay, that's about it, I think. Any questions?
Thanks, Sudhir. I had a question that you mentioned that you're interested in introductory HEP curriculum, and I'm wondering if you already had ideas about what kind of content would be in that curriculum.
So I think we have an idea, because that's how we are basing this first activity at Fermilab. So we plan to have a basic session on Python, and then an advanced session, and also before that have a GitHub, GitLab kind of a session also. The thing is that our students are familiar with Linux, so they may not get so much benefited. So while your training part starts from that, we would like to remove something and add something. So that's the kind of thing we want to work, if that fits your schedule. It's not that the things we add you will have to teach, but the thing is that you come with a core well set curriculum. So we wanted, if we could modify that to and work with you somehow.
So
but we do have ideas. Yeah.
So this is Peter. So it looks a little bit more like maybe a data carpentry's curriculum, which is that there's some pieces from some but not all from the software carpentry's curriculum that we think would make sense for our community. And then some pieces we would add which would sort of lead into the sort of more data specific aspects of HEP.
Yeah, I guess my question was a little if you had any group or discussion about what you thought of as the core competencies, because that would be a good starting place if you had already that information or conversation.
What we have is basically experience from running schools at multiple levels in that tier. Basically, more so the in this pyramid, the second and third level in the tier. We have lots of experience. It's really the introductory level. Yeah, exactly. The introductory level that we're sort of trying to understand how to develop, and this is in particular the goal of the NSF Cyber Training Project. First step. That's the introductory level. The Software Institute is more the developer training and the mentor level, the higher tiers, to be clear. What we have is, just basically our understanding from having run second and third tier level courses, what is missing at the earlier levels. And we have this survey, which Sudhir referenced, which we just basically ask people at various stages in their career. I think I showed you, Tracy, this at one point, maybe almost a year ago. We finally put it out this past fall to get some sense of what people think they need, right? So that's the other piece of input we have.
One thing you might find interesting as well, the HSF training organization on GitHub has a repository called Analysis Essentials, and was originally the sort of beginning to the LHCb starter kit, and it was taught, I think it was a one-day course that was taught right before the starter kit for people coming in who did not have experience in some of the very basic things. So if they didn't have Git experience or Python, so it covers Python, Git, and Unix. I'll send a link there, but that's the HSF. It's part of the HSF training now. You can maybe look at that and get an idea of sort of at least where some of the people in the starter kit thought people were deficient.
So I think it's very nice to have that material, and there's a few other things that we've developed as well. And one of I think the most important things we've discovered is that, of course, what you don't want to do is hold people back. So you want to give people all of the freedom that they want to develop the material they think they need, but then share it. And courses that I've written, I know have been taken by Bell 2 and taught as part of their starter kit activities. But Sudhir, I think in some ways what we're lacking, though, is we have lots of these activities, but like you said, we don't really have a well-defined forum where people who are interested in this can come together and share ideas. So I think that is a very important thing, which I think First HEP and Iris HEP can help us to get. And I suppose also the session that we'll have at the JLab workshop is a very good chance to bring a lot more people on board and discuss ideas about training. But I do like the idea also that we have some quite concrete goals of what we actually want to achieve, on a time scale of 3, 6, 12 months.
So Graham, I think that the lesson from both from the carpentry, software carpentry, data carpentry, etc., and a little bit from even our high energy physics experiment experience, in particular HCB, is that this sort of community building is almost as important as the rest.
Yep.
Right? That there's a set of people that sort of feel, there's a lot of people that are interested in this. It's really surprising how many people are motivated to actually explain things to other people. We work in an academic environment, and people that are motivated to do this, to sort of provide a sort of structure within our community that people can engage with, right? Even more so than the specific goals we have, right? The building community part is almost as important as the specific goals of what we do with that community, right? Like revolution, right? Or whatever. Fine. That I think is quite important.
So I don't disagree with that, Pete. I just think that also having the goals helps build a community.
Yeah, no,
build a community around an objective, not build a community and then set an objective.
It's clear that things go hand in hand. But I think this is one of, go ahead, Tracy, please.
That's a little why I was asking, I think, about the core competencies too, because that can be a good thing to get community excited talking about. Like, let's walk out of the today having identified what we think of are the core skills that people need to know. Because it doesn't involve writing curriculum, which is hard and also maybe more, one or two people, but it can create shared discussion about what's important and then shared buy-in to the direction that you're headed with your training. Rather than, I think that a lot of times when you've had a lot of experience, you have the ideas in your head of what you should teach, and they're probably right. But there might be things that you would have missed, but that community effort of together deciding on those things is valuable. So I don't know if that speaks to your idea of like shared objective, shared purpose. Maybe it's a starting place.
I think, Tracy, one of the exciting things that we can offer, because people are paying a company's membership, et cetera, is really the instructor training. Is that we can organize that for some set of people, and that's sort of, so Graham is very familiar with the fact that we work in this environment where there's lots of people whose research time is on high energy physics, and we're enthused by this, but finding the funds and bandwidth and sort of paid people's time to actually focus on training is kind of an additive thing, right? Much less in explicit carpentries membership, for example. So I think one thing we can do this coming year that could be quite exciting for people is to have, whatever it is, 15 people or something like this, that actually get explicit training, right? Where like they're present for a workshop, and it's about training in how to be effective as instructors, right?
Yeah, definitely. That definitely helps. And then even after that to say, I guess like someone was mentioning, how will those people continue to talk to each other, right? So not having it just be a 2-day workshop and then they leave and never talk to each other again. But, let's create a forum or a mailing list or decide to have monthly meetings or something like that as, again, sort of that seed.
So the good thing about these 15 people, for example, would be that they can be volunteers for carpentry if they wish to, and they will be volunteers for our field also, because they would most probably come from HEP.
Yeah, I think the one thing that we have in high energy physics is the follow-on mechanism, which is that if we actually get people sort of put it on the table, you're going to do some training in this. We have this mechanism by which you can then be impactful in our this international community. But we have the mechanisms to do the follow-on part. I think the new and exciting thing is that we just actually say training is actually a first-order thing, and here's an opportunity to actually learn how to do that well in a structure in which you can fit, as opposed to being sort of a completely ad hoc, invented thing that people do with their left hand, the right-handed people do with their left hand in their spare time, right? So I think it's quite exciting where we are.
Yeah, definitely, to give it more credibility, to sort of elevate it in professional development. Those are really important. And saying, we want you to use this time to teach, not like, you should pretend you're going on vacation so that you can teach, right? But to really value that time and give people the space to do it and say thank you and we're glad you're doing this is really important.
Exactly. So we kind of referenced it. I think that Sudhir referenced it. I think the thing that we're interested in specifically in terms of the carpentries is probably something that's a little bit more hybrid, that looks like a little bit more like data carpentry, which has some elements of software carpentry, but then has some pieces which are, our community, for better or for worse, the physics community has, on average, I think, a little bit more sophistication in terms of what we can expect from the average graduate student in terms of skills. So it's a little more sort of less Unix intro and a bit more sort of Python, advanced Python, and then some data specifics. Is it possible to define sort of a little bit more data carpentry-esque hybrid curriculum?
Yeah, definitely. I think that would be that seems like the right approach.
I mean, you have it for the Astro people, right? I would call that hybrid. I don't know.
Yeah, it'll be similar there too. Yeah.
In which we would reuse, for example, the Python plotting elements of the carpentries, and maybe there would be external instructors, but there would be these additional pieces for which we'd probably have more hydrogen physics people that would be engaged in developing in the curriculum. Okay. Other questions either for Sudhir about where we're going, what we're trying to accomplish, or for Tracy, what the carpentries is about? Okay, then, well, thank you both Tracy and Sudhir for the talks, and I think this has been informative, and I think we're going to do great things. And we'll all be in touch, I'm sure. And have a nice evening, everybody.
Thank you.
Thanks so much for the invitation.
Bye.
Look forward to
Tracy.
continuing to talk with you.
Bye.
Nice to meet you, Sudhir.
Same here. Bye.
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 Bye, Pete.